Hello guys, in this lecture we are going to see the types of energy audit. This lecture is the continuation of last lecture. In the last lecture we discussed about the definition of energy audit principle and need of the energy audit. Now let's start with the types of energy audit. The term energy audit is commonly used to describe the broad spectrum of energy study ranging from a quick walkthrough of a facility to identify major problem areas to a comprehensive analysis of the implication of alternative energy efficiency measures sufficient to satisfy the financial criteria of sophisticated investors. Numerous audit procedures have been developed for non-residential buildings, which is described by ASHRAE, that is called as ASHRAE, and also defined by IEA, and also defined by the CRARTI 2000. Audit is required to identify the most efficient and cost-effective energy conservation opportunities or measures. Energy conservation opportunities or measures can consist in more efficient use or of partial or global replacement of existing installation. When looking to the existing audit methodology developed in IEA by ASHRAE and by CRARTI in year of 2000, it appears that the main issues of an audit process are: first issue is of the analysis of building and utility data, including study of the installed equipment and analysis of energy bills. Second issue is the survey of the real operating conditions. Third, understanding of building behavior and of the interaction with the weather, occupy and operating schedules. Fourth, the selection and evaluation of energy conservation measures. Fifth, the estimation of energy saving potential. And the last issue is of the identification of customer concerns and needs. Common types or levels of the energy audits are distinguished, that I'm going to elaborate within a few minutes. Although the actual tasks performed and the level of effort may vary with the consultant providing services under the broad heading. The only way to ensure that a proposed audit will meet your specific needs is to spell out those requirements in a detailed scope of work. Taking the time to prepare a formal solicitation will also assure the building owner of receiving competitive and comparable proposals. General four levels of analysis can be outlined as: level 0, that is benchmark. This first analysis consists in a preliminary whole building energy use, which is shortly called as WBEU. WBEU, whole building energy use analysis, based on the analysis of historic utility use and cost and the comparison of the performance of the buildings to those of similar buildings. This benchmarking of the studied installation allows determining if further analysis is required. Level 1, that is walkthrough audit, preliminary analysis made to assess building energy efficiency, to identify not only simple and low cost improvements but also a list of energy conservation measures to orient the future detailed audit. To orient the future detailed audit. This inspection is based on visual verifications, study of installed equipment and operating data, and detailed analysis of recorded energy consumption collected during the benchmarking phase. Next is level 2, that is detailed or general energy audit. Based on the result of the pre-audit, this type of energy audit consists in energy use survey in order to provide a comprehensive analysis of the studied installation, a more detailed analysis of a facility and the breakdown of energy use, and a first quantitative evaluation of the energy conservation measures selected to correct the defects or improve the existing installation. This level of analysis can involve advanced on-site measures and sophisticated computer-based simulation tools to evaluate precisely the selected energy retrofits. And the next is level 3, investment grade audit. In that, the detailed analysis of capital intensive modifications focusing on potential costly energy conservation requiring rigorous engineering study. Let's see the somewhat detailing about the benchmarking. The impossibility of describing all possible situations that might be encountered during an audit means that it is necessary to find a way of describing what constitutes good, average, and bad energy performance across a range of situations. The aim of benchmarking is to answer this question. Benchmarking mainly consists in comparing the measured consumption with reference consumption of other similar buildings or generated by simulation tools to identify excessive or unacceptable running cost. As mentioned before, benchmarking is also necessary to identify the buildings presenting interesting energy saving potential. An important issue is in benchmarking is the use of performance indexes to characterize the building. These indexes can be comfort indexes, which means comparing the actual comfort conditions to the comfort requirements. Another index is nothing but energy indexes, which is consisting in energy demands divided by heated or conditioned area and allowing comparison with the reference values of the indexes coming from regulation or similar buildings. And another index is nothing but the energy demands directly compared to the reference energy demands generated by means of simulation tools. Typically, benchmarks are established based on the energy outlets, means loads within the building, and that are then further passed into base loads and weather sensitive loads. These are established through a simple regression analysis of energy consumption and demand correlated to the weather data during the period for which utility data is available. Aggregate base load will represent as the intercept of this regression, and the slope will typically represents the combination of building envelope conditions or conduction and infiltration losses, less losses or gain from the base load themselves. For example, while lighting is typically a base load, the heat generated from that lighting must be subtracted from the weather sensitive cooling load derived from the slope to gain an accurate picture of the true contribution of the building envelope on the cooling energy use and demand. Now next is the walkthrough or preliminary audit. The preliminary audit, alternatively it is also called as simple audit or screening audit or walkthrough audit. The preliminary audit is the simplest and quickest type of audit. It involves minimal interviews with site operating person and a brief review of facility utility bills and other operating data, and a walkthrough of the facility to become familiar with the building operation and to identify any glaring areas of energy waste or inefficiency. Typically, only major problem areas will be covered during this type of audit. Corrective measures are briefly described, and quick estimates of implementation cost, potential operating cost saving, and simple payback periods are provided. A list of energy conservation measures requiring further consideration is also provided. This level of detail, while not sufficient for reaching a final decision on implementing the proposed measure, then it is adequate to prioritize energy efficiency projects and to determine the need for more detailed audit. Next is general audit. The general audit, it is also called as mini audit. The general audit expands on the preliminary audit described just before a minute by collecting more detailed information about the facility operating and by performing a more detailed evaluation of energy conservation measures. Utility bills are collected for a 12 to 36-month period to allow the auditor to evaluate the facility's energy demand, rate structures, and energy usage profile. If interval meter data is available, then the detailed energy profiles that such data makes possible will typically be analyzed for signs of energy waste. Additional metering of specific energy consumption systems is often performed to supplement utility data. In-depth interviews with facility operating person are conducted to provide a better understanding of major energy consuming systems and to gain insight into short and long-term energy consumption patterns. This type of audit will be able to identify all energy conservation measures appropriate for the facility given its operating parameters. A detailed financial analysis is performed for each measure based on detailed implementation cost estimates, site specific operating cost saving, and the customer's investment criteria. Sufficient detail is provided to justify the project implementation. The evolution of cloud-based energy auditing software platform is enabling the managers of commercial buildings to collaborate with the general and specialty trades contractors in performing general and energy system specific audits. The benefit of software enabled collaboration is the ability to identify the full range of energy efficiency options that may be applicable to the specific building under study, with lifetime cost and benefit estimates supplied by the local contractors. And the next is investment grade audit. In most corporate settings, the upgrades to facilities energy infrastructure must compete for capital funding with non-energy related investment. Both energy and non-energy investments are related on a single set of financial criteria that generally stress the expected return on investment. Return on investment, it is shortly called as ROI. The projected operating savings from the implementation of energy projects must be developed such that they provide a high level of confidence. In fact, investors often demand guaranteed savings. The investment grade audit expands on the detailed audit described as before the minutes, that is extension of or expanse of general audit, and relies on a complete engineering study in order to detail technical and economical issues necessary to justify the investment related to the transformations. In that, most important part is concern, concerning about simulation based energy audit procedure for non-residential buildings. A complete audit procedure very similar to ones proposed by the Ashri and Karthi in the year of 2000, and it has been proposed in the frame of the Auditech and Harmonac. Auditech and Harmonac, these two are the projects to help in the implementation of energy performance of buildings, and directive in the these two projects are directive in the Europe and to fit to the current European market. Now just we will see the procedure proposes to make an intensive use of modern BES tools at each step of the energy audit process, from benchmarking to detailed audit and financial study. The first step is of benchmarking stage. While normalization is required to allow comparison between the data recorded on the studied installation and reference value deduced from the case studies or statistics, the use of simulation models to perform a code compliant simulation of the installation under the study and allows to assess directly the studied installation without any normalization needed. Indeed, applying a simulation based benchmarking tool allows an individual normalization and allows avoiding size and climate normalization. Second step of the process is nothing but preliminary audit stage. Global monthly consumption are generally sufficient to allow an accurate understanding of the building's behavior, even if the analysis of energy bills does not allow identifying with accuracy the different energy consumers present in the facility. The consumption records can be used to calibrate the buildings and system simulation models. To assess this existing system and to simulate the correctly the building's thermal behavior, and the simulation model has to be calibrated on the studied installation. The iteration needed to perform the calibration of the model can also be fully integrated in the audit process and help in identifying required measurements and critical issues. Next stage is of detailed in a detailed audit stage. At this stage, on-site measurements, submit metering, and monitoring data are used to refine the calibration of the BES tool. Extensive attention is given to the understanding not only the operating characteristics of all energy consumption systems, but also situations that cause load profile variation on short and long term base. And the last stage is of investment grade audit stage. At this stage, the results provided by the calibrated BES tool can be used to assess the selected energy conservation measures and orient the detailed engineering study. These are nothing but the types of energy audits. Thank you for listening to me. Thank you very much.